In GCSE chemistry, there are a range of different questions that can involve looking at gas concentrations or gas volumes. So, in this video, I'm just going to look at 3 different questions that could look at gas volumes. So, we start off, so the question goes, the graph shows the moles of hydrogen produced during electrolysis of water. Calculate the volume of gas after 4 minutes. So the first thing that you need to do in this question is to go and work out the number of moles after 4 minutes, which you can read straight off the graph, right? So you'd go to 4 minutes, read it up. So in this example, we've got 4 moles of gas in 4 minutes. The second part of the answer comes from using your equation to work out the volume of gas. So you need to remember that the volume of gas is equal to the number of moles times by 24. That 24 is technically 24 decimeter cubes. So in this example, we'll go 4 moles. For the 4 moles that we've just worked out, we'll just read off of our graph, times that by 24 to give us a final answer of 96 decimeter cubes worth of gas. The second calculation that I want to look at is where we're going and we're reacting 2 masses together. So in this question it says 212 grams of sodium carbonate is reacted with excess hydrochloric acid. If it says excess hydrochloric acid, it means that you don't have to worry about the mass of hydrochloric acid. The reaction is shown below. So the reaction is shown below. Always make sure that you go and double check that reaction, because it shows you the number of moles of, in this case, sodium carbonate to the number of moles of hydrochloric acid that's being used and the number of moles of your products on the other side. So what volume of carbon dioxide will be produced? So this question involves using a few different bits. So we're going to have to use our equation for the volume of gas, but we're also going to have to go and work out the number of moles and look at a few ratios. So it's pulling lots of bits together. But if you do it step by step, then it's not actually as difficult or as daunting as it appears to be. So the first thing that you need to do is to work out the number of moles of sodium carbonate. So we know that we've got 212 grams of sodium carbonate, and we know that 1 mole of sodium carbonate is 106 grams. You can go and work that out by using a periodic table and working out the relative formula mass of sodium carbonate. So the next thing that we need to do is to work out the number of moles. So 212 divided by 106 gives us 2 moles of sodium carbonate. The next thing we need to do is to work out the ratio of sodium carbonate to carbon dioxide using that equation. So you can see in that equation that for every 1 sodium carbonate we also get 1 lot of carbon dioxide. So there's a 1-to-1 ratio. So therefore, we know if we've got 2 moles of sodium carbonate, we must have 2 moles of carbon dioxide. And finally, to work out the volume of carbon dioxide being produced, we use our equation for gas volume, which is the moles, which is 2, times by 24, which will give us a volume of 48 decimeter cubes worth of carbon dioxide being produced. The final equation, or the final set of questions that I want to look at, looks at going and getting some data out of a table. So the question goes, the student sets up the equipment above to measure the amount of gas produced in a reaction. The results are shown in the table. If it's talking about the results being shown in the table, make sure that you go and have a good look at the table. How many moles of gas are produced when 0.23 grams of sodium carbonate are reacted? So the first thing that we need to remember is that the gas that is being given to you in this table is in centimetre cubed, and really we need it to be in decimetre cubed. So remember, to get from centimetre cubed into decimetre cubed, all you do is divide it by 1000. So we need to remember that we're going to be using our equation for the volume of gas, which is moles times by 24 decimetre cubed, gives us the volume of gas. We're going to have to rearrange that though, because we're looking for the number of moles. So the first thing to do is to go and read the volume of carbon dioxide being produced off the table. So just go to 0.23, go and read it across, which will give us a volume of gas of 52 centimetre cubed being produced. So, to work this out, start off by changing that 52 centimetre cubed into decimetre cubed. So we're going to do that by doing 52 divided by 1000, which would give us 0.052 decimetre cubes worth of gas. The next thing we're going to do is to rearrange that equation. So the volume of gas divided by 24 will give us the number of moles. And finally, we're going to go and put our numbers in that we've previously worked out. So we've got 0.052 decimetre cubes worth of gas divided by 24, which would give us 0.002 moles of carbon dioxide being produced. If you're unsure about any of these questions, go back, watch them again, and remember that they're not as difficult as they first appear. You just have to take your time when answering them and make sure that you take things step by step rather than trying to do all of it in one big jump.